So resist force that occurs when two objects slide by each other, we call that friction. It's always resistive. So if an object's moving one way, then friction would be the opposite way. The reason for it in the first place, like why there is this resistive force, let's take a look at an object. If we took say a microscopic view of an object, or a surface, I should say. Even though this table looks super smooth, and even though this book looks very smooth, if we looked at it under a microscope, what would it look like? Okay, bumpy, right? It would look rough, it would look bumpy, it would have a bunch of little grooves. You guys remember from biology days how things looked under microscopes? They would have like these little ridges, they'd have edges, it wouldn't be perfectly smooth. And so what happens is, if this is, say, the book, and this is the table, as they slide by each other, there's going to be some resistance. And actually, why don't we just do a little mini demo with yourself. Why don't you take your fists, okay, and your knuckles represents the grooves, and go ahead and try to slide your knuckles by each other. So what happens is you try to slide them by. Well, can you feel that resistance? Okay, if you don't touch, easy to do, right? If you now touch together, you can feel the resistance as they're bumping into each other. And that's what happens right here. These grooves bump into these grooves, the little hills here bump into these, and that's what slows it down. That's where you're going to get kind of this resistance. Okay? What happens if I put oil on the surface? Fills in the grooves. Good. So if we put oil on the surface, it fills in the grooves, right? And essentially, what are you doing? Okay, you're smoothing out the surface, right? By filling those grooves in with some kind of lubricant or oil, it's going to go ahead and smooth out the surface, reduce the amount of friction that you have. All right? Okay, so there's two factors, really, that affect friction. And one is kind of obvious and one is less obvious. Can someone think of one factor that might affect how much friction there is between two surfaces? Yeah. The speed, not quite. So if you're going fast or slow, you're still going to have friction. Yeah. There is something separate, and we're not going to get into this yet, but it is true that it's harder to get something going than it is once it's already moving. But we'll touch on that a little bit later. Yeah.
Just the surfaces in general. Like if you were on a whole bunch of rocks and you were trying to ride a bike, it would be a lot harder because of the friction.
Okay, good. So one of the factors is how rough the surface is. Okay, so if you go out on a ice skating rink, run, jump onto the ice, you're going to slide a good amount of distance, right? If you go out on a baseball diamond and slide on the sand, right, you're going to stop pretty quickly. So the rougher the surface, the more friction that there's going to be. So that's one of the factors. So let's just let's keep going with this, and then we'll talk about number 2. So we call this the coefficient of friction. So the value we use would be basically the coefficient of friction tells you how rough the surface is. So the larger the rougher the surface, the larger the number would be, the larger the coefficient, the smoother, the smaller. The symbol we use for this is a Greek letter. Looks like this. Anyone know how we pronounce that letter? Yeah? Mu. Good, that's a mu. M-U. So anyway, that's called mu, and that's our coefficient of friction. How rough the surface is. Larger number, rougher, smaller number, smoother. Okay, so that's one factor. There are two. Yeah.
Can be the normal force of the force remain then.
Okay, good. So let's call this, so it is specifically, it's the normal force. And you guys remember what I defined the normal force was? It's perpendicular. It comes from the surface. So it's how hard the surface pushes against the object. Okay, how hard the surface pushes against the object. So let's go back to our knuckles. Let's show how this will affect it. So if you just barely graze your knuckles, go ahead and slide it. Not too hard, right? Pretty easy to do. Now try to push your knuckles hard. So if you push them hard against each other, then try to slide. Okay, much more difficult, right? And maybe painful a little bit. So that one, as you slide by, it's much, much more difficult. So same thing. So as these surfaces push against each other, it's kind of like the grooves have a harder time sliding by each other. And therefore, there's going to be more friction in that case. Okay? So that's the second factor. Remember, the normal force is not necessarily the same as the weight. So if this was my book, let's say my book's 100 newtons. It's pushing down 100. How much is the table going to push back up? 100. However, if I put Bufar on top of this, let's say he's 50. If this is 100 and this is 50, now how much is the table going to push up? 150. So now the table has to push up with more force. If I were to push down with another 100, now how much is the table going to push up? 250. In each of those times, there's going to be more and more friction because the table's pushing up harder and harder and harder. The grooves get caught more and more and more. Okay, so that's friction. That's kind of the definition. That's the concept of friction. The formula for friction, well, we could derive this ourselves. If we have friction equals, well, as the surface gets rougher and rougher, what should happen to the amount of friction? It should increase, right? So that's a direct relationship. So we'll just write mu. So if mu doubled, friction would double. Okay, nice direct relationship. What about the normal force? As the surfaces push harder against each other, what should happen to friction? It should also increase. As they push harder and harder, it's going to go up higher and higher. So that's a nice direct relationship as well. If the normal force were to double, then frictional force would also double. Okay, that's it. That's friction. Any questions on the concept of this? Make sure you know the difference between the force of friction and the coefficient of friction. Questions will often ask for one or the other. They're not the same. Coefficient is how rough the surface is, a number. Force is the actual force from friction. Yeah.
Is Fn that force normal?
Oh yeah, Fn is the normal force. F sub n is our normal force. Thank you.